All right, here we go, kids. 5-5. Sorry we're jumping around. We kind of skipped 5-4. We'll come back to that one. 5-1 we don't ever do. Well, here we are. We are looking today at spread. How does the data spread for us in a particular set of data? Maybe the best way to do this problem is not to talk through the theory on the front end, but just dive into the problem. And then I'll go back and summarize with the theory. So if in your notes, I'm in my second column. All right? Now, this is a ice fishing contest, and you need to create a report. Maybe the DNR, I don't know who wants, but they want a summary, right? So you create what we call a box plot, or some people call a box and whisker plot, to summarize. And sadly, your ice fishing contest didn't have a ton of people. We can see that there were 13 different fish that were brought to the table to be judged. The first thing we need to do with these 13 fish is put them in order. All right, so as soon as you get those, you kind of need to, like, what's the smallest, what's the next smallest, and I am just going to paste that in there. There they are. There are the 13 numbers placed in order. Then we need to create what we know is the 5-number summary. 3 of these are going to be super easy to find: the minimum, the median, and the maximum. These are things that we've talked about already. We can clearly see the minimum and the maximum. We need to find the median. Be careful on the median. It's kind of the trickiest of them. Remember, the trick is take the 13, divide it by 2. That gives me 6.5. So now I know that the 7th item is my median. All right. Counting out, 1, 2, 3, 4, 5, 6, 7. There it is. Circle it and put it in your list. Now we need to find the Q1 and the Q3. What the heck, Q1, Q3? What weird names. It'll make more sense in just a moment. We need to take the bottom half and the top half and think about this as 50%, and this is 50%. Now, it's not exactly 50% because notice we've kicked out 13, but this is about the bottom. That is about half of the top. Okay? All right, so we have our 50%ers. Now, what we're going to do is take this set and break it into 2 parts. 2 equal parts. So just like we broke the median, breaks the whole set into 2 parts, we're going to take the bottom half and break it. We clearly see there are 6 items. So the median will be in between those 2. And we do the same thing in the top half. Cut it in half. And now we ask ourselves, what number is in between or in the middle of 10 and 10? And we say 10. So that's called Q1, and then 15 would be Q3. Maybe you figured out why they're called Qs. Now I have broken my data set into 4 pieces. Each one represents 25%, aka a quarter. So this is quartile 1, quartile 3. And you could think of 13 as quartile 2, if you like to see a nice little pattern of 1, 2, 3. But we call it the median, so that's why we don't label it as Q2. And the minimum would be Q0, and this is Q4. So this is the marker, the number that cuts off the first quartile. The median cuts off the second quartile, aka actually the second half, the third quartile, and the fourth quartile. All right. IQR. That's the next thing we need to figure out. This is called the inner quartile range. Whenever we use the word range, that typically means some value minus some value. So in this case, the inner quartile range would be take your Q1 and Q3 and subtract those. So I'm going to write here Q3 minus Q1. In this case, 15 minus 10 is 5. Now, one of the big points of doing a box and whisker plot is to establish whether or not we have what's known as an outlier. To know if a number is an outlier number, to know if a number is weird, yes, you need to know what's the limits of normal. If you'll give me a moment, somebody at my door here. Do you have a moment to wait? Thank you. Come on in, have a seat. So my limit will be, I'm going to take the 5, which is my IQR. I'm going to multiply that by 1.5, and that's going to give me 7.5. And 7.5 is the distance that we can go and still be considered normal. Now you're probably wondering 7.5 from what? Well, so to get the lower limit, we take Q1 minus 7.5. So in this case, I'm going to take 10 minus 7.5, and I get 2.5. And so 2.5 is my lower limit. And if I look at my fish, my lowest fish length is 6. Therefore, all my fish lengths are fine because everything is above 2.5 inches. Okay? Again, for the upper limit, I take Q3 plus, this time, not minus, 7.5. So that would be 15 plus 7.5, which is 22.5. So this is my upper limit. And notice now, if I look at my upper limit fish, my largest fish is 24 inches, well above 22.5. So we now know we have an outlier. The 24-inch fish is an outlier. Notice how in my sentence I used context, inches, and fish, right? I didn't just say 24 is an outlier. All right, another thing that we could notice in this data set, well, before we do that, we should make a picture. This dotted line that I have here is a picture. All right, so my lowest value that I need to graph is 6. My largest graph value is 24. So I'm going to start at 0. And I'm going to go out and go by tens initially. And that's going to give me room to graph those numbers. Now, in between are the half markers, 5 markers, right? So 5 and 15. And now I know 25 should be roughly there. All right. When you create a box plot, make sure that you put your dots above and below, not on the line. Okay, so in this case, I've got a little bit of space above my graph, so I'm going to put my dots up there. So we start with 6. Put a dot. 10. See where I'm getting these numbers from? Yep, just the 4 dots that we have here. 6, 10, 13, 15, 24. Place them on there. All right, next thing we're going to do is draw a whisker between the outer ones and the next inner ones. Those are called the whiskers of the graph. They're just lines, straight lines. In the inner ones, we're going to create boxes. The way I draw the boxes is I draw little vertical lines between those, on those 3, and then I connect them up. So there's my left, my second quartile, and there's my third quartile. All right, so here is 25% of the data, and 25% of the data, and 25% of the data, and 25% of the data. Now, one of the reasons we make this is that it also shows us not only the spread, it kind of gives a little hint at the shape of the graph. Can you tell which way this data is skewed? Hopefully you see that the left-right whisker is skewed longer. Therefore, the fish lengths are skewed to the larger, or we would say, in this case, right. One final note. Because 24 is an outlier, we actually should kick out the 24-inch fish from the data set. All right, what that means is my graph would actually look like this. Everything else would be the same, okay? We would kick 24 out. The next largest fish is 17, so that red graph is typically what you'll see, and then out here they typically put a little X showing the outlier. Okay? Well, that's the lesson. That's how you create box plots, is they represent the data on a number line using these kind of 4 regions. Yeah? It shows 4 groups. It uses 5 values. Make sure that you know those 5 values, the minimum, the maximum, the median, quartile 1, quartile 3. Okay? And then we need to use that information, especially Q1 and Q3, to help us find IQR, which helps us find the limits, which tells us what's the upper and lower limiting values of my data set. Good luck on the homework. Hopefully those 3 problems won't present too much of a challenge. Draw those graphs, write those sentences, report your results. Mr. Larson out.